Okay, hi again, and this is Chipmaster. Alright, so in this video series I will be repairing a MacBook that's not turning on. Alright, so it's written on it, charging IC. So let's zoom in. Alright, so as you can see, it's written charging IC. That's all that is written on it. I don't know why, and I don't know what's wrong with it. This is the first time I'm actually going to check this thing. Okay, so I'm going to plug in the charger now. I already have my charger connected already to the camera. Let's go over to the fourth camera. As you can see, it's taking 5 volts and the current is 270, 250, 265, 200, and it's jumping, it's fluctuating. Alright, it has 4 ports. Let me try the next one. Alright, so it's taking 5 volts, so it's not boosting to 20 volts. As you can see, there's proper communication because there's a blue light that is coming out of the side here. There's a blue light that's coming out of the side here of this USB-C tester. Right, there's a blue light there indicating that all is well on that port. Let me try the other port. And I'm not getting any blue lights on this side. Let me plug it out again and plug it in. See, I'm getting 5 volts. It's sensing the 5 volts, so the configuration channel bus is working, but there's no lights coming out the side here. Let me see if I can angle this. Oh, I have so many wires here. Let me. Alright, so let's try the next port. I get 5 volts and no blue light on this side also. So let's try the next side. So there's something wrong on the right side of the MacBook. Let's try the ports on the left. As you can see, I get 5 volts and the blue light is there. As you can see, there's a blue light here at the side. So as I plug it out, the blue light is gone. Let me try the next port. See, the blue light is there. That indicates that this side is also okay. But on the right side, when I plug it in, as you can see, goes to 5 volts, but it's not boosting. No blue lights at the side. Next one, no blue lights at the side. Right, so this has a total of 4 ports. So as you can see, so this side of the MacBook having a problem here. Right, this side is good. So this side, each ports on this side, when I plug in the Type-C charger, I get blue lights, 5 volts, 270 to 265 milliamp, fluctuating back and forth. On this side, no blue lights, and the same current is jumping back and forth. Alright, so that indicates that there's something wrong on this side. Right, so there are 2 configuration channel power delivery chip that is used to talk to the charger in order for the charger to boost to 20 volts. Right, so this is how a typical Type-C charger, any Type-C communication works, that uses a power delivery, right, and it's done through the configuration channel, which is the CC bus. Right, so I'm going to take apart this laptop now to see what is going on inside of it. Okay, just moving the camera out the way. Just go out a little bit. I don't think I'm getting a good angle. Yeah. Let me go back a little bit. Okay. Okay, so first of all, I'm just going to inspect this surface section of the board to see if any water spill or any burn, any explosion that is on the board. And it looks clean. Looks pretty clean. Just dusting out the laptop here in the bin. It's a bit dusty. Alright. This one has a lot of screws and some compartments, but it's worth the it's not that bad. Should be up in a few minutes. Oh, I didn't plug off the battery. Why didn't you remind me to remove the battery first? Oh, did I forget that? You couldn't remind me, guys, that I didn't plug off the battery. Because I was saying wait, but I didn't unplug the battery a while ago. And I'm here taking apart the laptop and the battery is not removed. But it's not that serious anyway, ain't it? We all forget things sometimes. I don't like taking apart these laptops, these models, because of the fan connector. When you're about to put it back in, this part keeps going back under the board, right? And then you have to take it out. And you put the side over. This part is going back under the board. I hate this model. Can be a pain in the ass sometimes taking apart these laptops. This is the mic. Oh God, what? This is a lot of clips and connectors. So much of them. Ugh. Alright, this laptop is actually pulling for the first time. It's actually disassembling for the very first time. Alright, so I'm at the final set of screws now that's actually holding down the board. So I'll just move them out the way now. It's the Wi-Fi. Oh, there's some screw under here. Normally when you feel something tight or not loose, they stop. It's a ribbon. So I'm lifting gently on this side. As you can see, I'm just lifting it my index finger here, and I feel something tight. Oh, see, there's another screw here that I missed. I'm doing it again. Ah, it's now loose. I'm taking my time. As you can see, I'm just using my index finger until it's all out. It's out the way. Alright, let's check this side of the board, and we have a lot of dust here. Dusty, in it. A lot of dust. This side as well. A lot of dust. Look at, see that? A lot of dust there. Let me dust it off. That's a common issue with the Chipmaster laptop. How the front of the head side, and also can trap liquid, also killing the MacBooks. So let's take a look now after cleaning. Alright, it's now clean to the point where I can work on it. So these are the power delivery chips, as I was saying before. Right, so one for each port. Right, so this is a power delivery chip for a port, and this one for the other port. Right, on this side we have one power delivery chip here, CD3217 B12, and we have another one here. Right, this black spot indicates that it has a software in it. This black spot indicates that it has an embedded program in it. It's not a watermark. The watermark for this board is actually on, let me see if I find the actual watermark. Let me zoom out a little bit. So this black spot here on the chip is indicating that it has an embedded program inside. It's not a watermark. If it's a watermark, it would be white. So the watermark is normally on this side of the board. I'm just looking. I haven't found it yet. The water indication when liquid gets the laptop, it indicates to the laptop that will tell you that it's watermarked. Oh, I see another one here. So these are the watermarks. Normally when they got wet, it indicates that, but normally when these chips have programs inside, they are programmable. Oh, I'm wrong. It's the actual watermark. It's correct. It's the watermark. This is the watermark indicator. So if it gets liquid, it changes its color. This chip reads an embedded EEPROM chip. Here is the EEPROM chip for the. This is the EEPROM chip for the CD3217. This is the EEPROM chip. As you can see, we have some corrosions there as well. So this chip reads this chip, right, and then configure the GPIO pins and then start to talk to the charger, right? So this chip is the main chip, right? This one goes through this chip to read this chip. So this chip on the other side, right, this CD3215 or the power delivery chip has to go through this chip in order to read this chip through the UART bus, right, which stands for Universal Asynchronous Report Receiving and Transmitting Information, right? So the UART, UART, which stands for Universal Asynchronous Receiving Transmitting of Data, which is a small data transfer speed, right, that is used for communication between two devices or electronic devices, right? So this is the EEPROM chip for this chip. These two chip also has, for this side, their EEPROM chip is right here. Here is it. This is the EEPROM chip. Let me zoom out a bit. Right, so this chip has to go through this chip in order to read this chip. Right, so this chip is the main chip, so it can read it directly. So if you plug in the charger, if you plug the charger in this side, right, this chip will go through the UART bus, then it will read the BIOS chip through this chip. So if this chip is faulty, then this port won't work, right? And if this chip is faulty, the entire system will be out of order. This is why we weren't getting the blue lights. So I'm going to connect the charger. So I'm going to take the charger port, sorry, the DC jack or the USB-C port. Alright, so I'm taking the USB-C port. Just taking one random, it doesn't matter, anyone can work. And I'm going to connect it to the board for testing purpose. Alright, there's it. Sorry. So I'm now just going to use this, clip this down for testing purpose. So as we checked earlier before, only one side is giving us good reading, the other side is not giving us proper reading, so it indicates that there's a problem on one side. Let me just connect both sides and see. So I'm just connecting the retentioner here to hold the tension on the clips for the type C port so it don't slip out of order on the connector. Alright, let me just remove this port because I don't remember which side is giving the trouble, so I can't bother to be removing and connecting to the next side and connect it to the other side. It's a bit annoying. Alright, so I'm now removing the other port. 21 minutes gone already. Alright, so I now have 2 ports here on each side. Alright, so I have 2 ports now. So I'm going to plug in the power now. As you take a look at the USB-C multimeter, or meter rather, and see which side is the troublesome part that's actually giving the problem. I'm just trying to connect the set like this camera. Give me a minute. Okay, so let me just connect the camera now. Right, so I'm gonna plug in the charger. Alright, so as you can see, I got the blue light on this side. Alright, so let me go again. Let me see if I can zoom in a bit more. Alright, so I see I get 5, takes the 5 volts. I got the blue light. Right, so zooming out now. As you can see, there's a blue light here at the side, so that indicates that blue light there, that indicates that there's right here. See a blue light here. Alright, the next side. Alright, good, I got the blue light as you can see. Alright, I'm doing the next side. No blue lights. Next side, I got 5 volts, no blue lights. So indicates that there's a fault on this side of the board. This side is okay, so I don't need to touch it. So I put my focus on this side, right? So there's a communication problem between one of these 2 power delivery chips that I mentioned earlier. So I'm going to go under the microscope now. But as I said before, I saw some corrosion here. So could this be my problem? Right here, as you can see, I have some corrosion there. Right here, this is the EEPROM chip. So if this chip is not in proper order, then the power delivery chip here will not be able to read the information inside. Right, so I'm going to use the oscilloscope now to check if this chip is actually reading the chip, right, and also check if this chip is actually reading through this chip in order to read the RAM chip. I wonder if you get what I'm trying to say right here. Right, so first I'm going to check if this chip is reading the RAM chip. This is the RAM chip, right? And also, as I said before, this chip needs to go through this chip in order for it to read the RAM. Alright, so I'm going to go under the microscope now. Alright, turn off this part. Alright, so now I'm under the microscope. let's. But it does it make a difference? This camera has such a brilliant zoom, and it's as if I don't really need a microscope either. Okay, so as you're looking here, we are seeing some corrosion on some of these resistors. They are strap-in and pull-up resistors, as you can see, and there's some disconnection going on here. One of the resistors is actually missing, as you can see right here. Right here. Right, there's a resistor missing right here. Right, this resistor don't look so good in terms of the solder joints. So these solder joints are all broken, and the resistor solder joints on the resistor are also gone due to this liquid corrosion here. Oh boy, this is a big mistake that is done by Apple in the engineering design of these housings, where liquid always come on this side due to the improper design of the air of the vents that are the cooling vents that allows the liquid to enter in easily. Right, so I'm just scraping away this oxidate up. One of the tweezer there has bumped off and gone. I'm just trying to expose the pads. Right, there are a lot of oxidation. I'm just going to take off this one. As you can see, it's not good, so I can just remove that. So I'm just going to replace them. These are normally some 30 ohm resistors. You can use 30 ohm resistors, I believe. Yes, should confirm with the schematic and the board view, with the schematic rather. Yeah, sorry about that, a call came in. Right, so as you can see, I was exposing the copper, right, so I can solder new resistors to them. Alright, I'm thinking of changing these resistors. Solder joint seems okay so far. Let me just clean it with some 99. See how it looks. Not too bad. Just want to expose this. Alright, there we go. There we go. Alright. Alright. Exposing these copper traces. Alright, it looks pretty much good. Alright, so as I said, I'm going to check if the chip is actually, the power delivery chip is reading the BIOS, this RAM chip. And this volts are the chip that is released from this chip. Double checking these resistors, making sure the solder joints are intact. So I don't think I have to change these. I don't think I have to change these at all. Don't think I have to change. Not change. All good. Good. That's good. That's good. That's good. That's good. That's good. That's good. All right. Now we have a disconnection line here, I believe. I think it's disconnected, this trace here. Let me just get to the multimeter and see if there's a trace or if it's broken. There. Yeah, it's broken. It's broken. As you can see, I'm not getting a continuity here, so I have to jump a wire as well here. Alright, so this is the pin, this resistor here. This is the pin number 1 of the chip. This is the chip select, right? So this is the chip select pin indicating which, this is to indicate which pin of this chip does this RAM chip is going to access its information to read the RAM, the contents inside of this RAM. Alright, so going on to the oscilloscope. Alright, so I'm going to check pin number 1. Looking for the probes here. Sorry. Alright, so my settings is already set. 500 microseconds, 1 volts, 2 volts per division, and my trigger level is set to 960 millivolts. So I'm going to connect the power. On the faulty side. Alright, there we go. Alright, so this is the resistor here. This side is the pull-up. This is a pull-up resistor. Right, so we'll check on this side. This is where the data is also going to read. Alright, this is this side. Alright, let's go. So I'm going to give power. Yes, there is reading right there. As you can see, the chip is actually trying to read. So what I'm going to do, I'm going to increase my time base to 10 milliseconds. Right, and I'm going to remove the power. I think I have too much light on this side. Let me the shutter, the aperture. Let me lower the aperture. There we go. Alright, there we go. Let's go again. Alright, so I give power. Again. Try the next one, port. Alright, so it's a quick read right there. There we go, there's a signal. So as you can see, it has read. So it has read it. I'm going to increase my time base again and go again. It happens very fast. One more time. Alright. Try the next port. So this port, again. Right, so there we got reading. Let's try again. There we go. There we go. Let's go again. There we go. One read. So we got a reading, and it stops because it's not finding a ROM. So it reads twice and then it stops. So I'm going to solder. I'm going to now solder. Oh, sorry, I wasn't under the camera, under the web, the microscope. Oh, I'm sorry about that. It was my bad. This is the pin here, right here. Pin number 1. Let's go. Alright, so as you can see, there is one read right there. We got one read there. Another read right there. As you can see right here, there's another read right here, and it's reading, and then it stops. So the chip is reading. So the chip is okay. The chip basic working conditions is already met, so it does need to read this RAM chip properly now in order to pass, configure its GPIO pins, and then now start talking to the charger through packets. So it sends a packet ready signal to the charger, and then the charger will now accept that packet ready signal and then now start to learn the capabilities of the charger and then issue the 20 volts. So I'm now just catching fresh solder on these solder pads here. And here. Alright, it's nice and shiny. Focus, double focus, focus. Focus. Right there. And right here. All right. Because of the amount of oxidation, it's a bit difficult. It takes some more time to get the solder to stick properly onto these pads because of the oxidation. So I had to do a lot of scraping to scrape away to expose the copper. Alright, I think that's it. So first, let me just check the resistance around these chips. Right, this is the main input, 3.3 volts, 3.3 volts. Right, so I'm going to check the resistance on those. It's dark. So let me sorry about that. Alright, I got my, how to adjust the camera aperture to get more light in the lens. Alright, so I'm checking here. As you can see, I get 481. That's good. Alright, this is 3.3 volts. This one is also 3.3 volts. Alright, I get 242, 240, 253. That seems good. Next side, also good. That's 20 volts coming here. Alright, bias chip, input, power supply, sorry, not bias, EEPROM chip for the power delivery chip. That's also good. .1 volt, also good. And this is the CC channel, configuration channel. Should get 500 and something right here. ES 554, that's good. CC1 and CC2, excellent. CC1 and CC2 are okay. Alright, so now I will solder these resistors, and then I'll check back with the oscilloscope to see if the chip is going to read correctly and boost to 20 volts. Alright, so I'm just going to get the resistor pack. These are 0201 resistors. So let's head over to the schematic. And I'll go over to the Shinjijao database. So we'll read the schematic. Okay, sorry about that. There's an issue with the server. It's not connecting, so I will use the resistance measurement on this side here for on the good side, and then I can make my adjustments and then get the correct resistor for the next side. So this is pin number 1. This is pin number 1. This is the mark, pin number 1. Alright, so I'll measure this resistor here to see what resistor is this one. And it's 15 ohm resistors, 15.7 resistor, as you can see. 15. Alright, and the other resistor on this side, that's 3.3K. And here are the rest on this side. 15.7, beautiful. And the other one is the same, 15, 33, you can use up to 33 ohm resistors as well, not a problem. And this one is 99, this is 100 ohm. $3.2K. So pin number 1 is connected to this one. Yes. Pin number 2. Pin number 2 is connected to this one. And this resistance is 15.4. Excellent. So they're all 15. Alright, so pin number 1 and 2, very important. Right. So there's 15. So let's go over to the next side now. Alright, so pin number 1, 2. Okay. This one is a pull-up resistors as well. 2. Let me go to the diode buzzer continuity, pin number 2. Alright, so pin number 2 is connected here, so this is another 15 ohm resistor should be placed here. Alright. Alright. Oh, sorry, I was blocking on the camera. So pin number 2. It's connected here. So there's 15 ohm right there. This one. Alright, that one is not connected. Let me pause again and check if the server is working. Okay, so I've after searched the web a while ago for a schematic and a board view, just for demonstration purpose. So here's the side that I'm working on, as you can see. So this is the EEPROM chip UB260, and as you can see, pin number 1, this is the pin that I was checking with the oscilloscope. As you can see, chip select. So it's called TBT_WR_SP_CS_L, which stands for Thunderbolt, right? Read and write SPI_chip select_L. So this is going to be a low signal when it's each time this PD chip here, this is the power delivery chip, reads this EEPROM chip, it will have to pull the signal low. That's why the L is there, indicating that it's a low signal. So it has to be pulled low each time it's going to be read, reading the contents of this RAM chip. Right, so these are the resistors that were having corrosion and their pads were broken. Right, so as you can see, it's the Thunderbolt SPI master in slave out, and this is SPI Thunderbolt master in slave out. Alright, and this is the pull-up line, normal pin, and this is the signal line. Right, so this is for the Thunderbolt. Right, so the Thunderbolt chip is here. These are the Thunderbolt chip, which is designed by Intel. Right, so these Thunderbolt chip must read the EEPROM chip as well. Right, but it doesn't really affect the functionality of the power delivery chips. So the power delivery chips have to be reading these chips at each time you plug in the Type-C charger. So it must read this EEPROM chip at all times during the initial stage of plugging in your Type-C charger. So this is a resistor that is missing. Right, so as I have a next part here of the schematic. As you can see, it's located it for me. Right, so as you can see, so RB, so this is RB293. So this is RB293, and it's a 15 ohm resistor, and I'll check them on the other side of the working side. Right, RB293, it's 15 ohm. Right, and the other resistor that is missing is, confirm, and that's I'm on this side, and that's the one below, above rather, and it's RB293 and RB29C. Alright, RB29C, also 15, so I need a 15 kilo ohm right here, another 15 ohm resistor here, and there's a missing one here, and that's the Thunderbolt chip select. This is the one that is missing, and it's UPC3_LDO, which is sending the 1.8 volts to this chip, right? And it's coming from this chip here, right? So this chip here is sending 1.8 volts through this resistor here, and from this pin to this capacitor here to power pin number 8, as you can see here, and this is 3.3 volts. Sorry, not 1.8 volts. 1.8 volts is for the T2 ROM. This is the T2 ROM. This is the T2 chip. Oh, so the T2 ROM is on the other side. This is the T2 RAM chip, as you can see. Pin number 8, 1.8 volts awake. So the T2 RAM is powered by 1.8 volts, so that's my mistake, sorry about that. So the T2 RAM, as you can see, is powered by this 1.8 volts here. Pin number 8, 1.8 volts awake, alright? So this is 3.3 volts for pin number 8 for this RAM chip. Alright, so I'll need two 15 ohm resistors here, and this resistor, which is 3.3 volts underscore LDO, which is the LDO through this resistor. This resistor is here as acting as a shunt resistor for limiting the amount of current that is going to the EEPROM chip here of this USB ROM. Right, so the resistor is very important to limit current. Right, it's used as a current limit resistor, or you can call it a shunt resistor, which is coming to the pin 1 of this capacitor to send 3.3 volts. So when this chip gets the 5 volts, it will automatically release this LDO signal, low dropout. LDO stands for low dropout. PP3V3_UPC_W_LDO sent to this capacitor here to power this chip to limit the current. So let's see how many resistance that is needed for that one, and that's that's RB263. So pin number 8, and here is it, RB263, and it is acting as a pull-up resistance as well. So that's a 3.3K resistor. Right, 3.3K resistor. It's a pull-up line for the read and write SPI chip select, and this is the write protect, which is for pin number 3, which is the read and write RAM write protect low, and for the chip select for reading pin number 1. So pin number 1. So pin number 1 is connected here. So pin number 1 is connected to here. Pull up. Oh, so this chip is acting as a two function. This resistor, so it's acting as a current limiting, and it is also acting as a pull-up resistance at the same time. So it's limiting the current, and it's also pulling up the voltages. So this side is 3.3 volts, and this side is acting as a pull-up line for the chip to read through this line here for the chip select. Right, pin number 1. See, right, TBT or Thunderbolt underscore read write and read underscore SP underscore chip select underscore low. Alright, so I'll just get these resistors and install them. Alright, so I need two 15 ohm resistor and a 3.3. So two 15 ohm resistors. So two 15 ohm resistors will be going here and here, and here is a 3.2 resistor for the pull-up line for the pin number 1 chip select. So we need a 15 ohm. Alright, so I have them here. Alright, so this is the resistor pack. Alright, so here we go. 1, 2, 3. So I just tip the edge of the tweezer with some flux. So I take up one there, as you can see I take up one. And I'm going to put it right there. These are brand new resistors, 15 ohm. Alright, so I'm going to put one here. Oh, I have to run that jumper wire because I have a broken trace right there. Right, on the hot here. And now soldering processing the start. Here we go. My hot air station is now set to 330 degrees because this is lead solder, so it's a low melt solder, so I don't need to go all the way up to 380 or 400 degrees because I already tinned them with low melt solder, which is have a melting point of 180 degrees. Alright, there we go, we have one installed. We need another one. I'm just adding some flux to the tip of my tweezer here to take up the other one. And there's the other one. Oh, the board is hot. Alright, there we go. I'll now place it here. Add some more flux. Oops, can't afford this to be blown away. Alright, so I'm going to just turn it around. There we go. Alright, so I'm just going to run a wire now between these two resistors, because it's a broken pad right there. So I'm getting the jumper wire. Oh, I'm gone an hour. My videos are so long. Alright, so here and here is a... I'm just gonna run the wire. Alright, there we go. And I will just cut here. Done. Alright, so now we need a 3.2 kilo ohm, 3.3 kilo ohm resistor here. Alright, so I'll just add that right there. Some flux. Now I'm going to look for the 3.3 kilo ohm resistor from the resistor pack. Alright, so 3.3, yes, here it is. So I need one 3.3 kilo ohm resistor. And it's right here. And I'm going to add some flux to the end of my tweezer to take up that resistor. There we go. Now I'm adding it to there, to that spot where I'm going to solder the new resistor. Let's go. Alright, that's done. So I will now clean the board with 99.9, making sure all is well, making sure all the solder, everything is soldered correctly. Alright, there we go. Alright, so I'm going to plug in the charger now. So I'm going to go back over to the power delivery, USB-C, meter here to check if we're actually getting somewhere with this for all this time that was spent. Oh, this camera is a bit heavy. Oops. Got it? Did I got it? Didn't got it. Let me try again. Alright. I got it. I want to show this side as well to see if you're getting the blue light. Yes, I got it. Okay. So let me go back to the overhead camera. Okay, so now I'm gonna plug in the charger. And let's see if it works. Alright, so I get 5 volts and I get blue lights. And I'm now getting 19 volts, and the laptop is actually powering up now. As you can see the current there. I don't know if you can see it clearly. I'm now getting 501 amp. I'm now getting 1 amp, so it's turning on now. So I'm getting 170 milliamp there, as you can see, and the blue light is there also, as you can see from this side. Let me see the blue light is there, and it's 20 volts. I'm getting 19 volts there, and it's turning on. Alright, so it works. So I'm going to put this thing together. Oh, alright, so okay, that was not a bad one. So the fault was on indeed that side due to the liquid. I have a lot of laptops to repair after this. So I'm going to see if I can repair at least 3 more or 4 more laptops before I leave. So I'll pause the video due to time. Alright, so I'm basically finished now, so I'm gonna connect the battery connector, which is the data line for the clock and data, serial clock, serial data, and the LCD connector. Sorry about that, I got a call. Is that right? It's not the correct screw. Alright, so just making double check everything is connected. Oh, we have one more screw here. And this screw was supposed to go here. Alright, so that's connected. That's why I have to recheck sometimes, because this thing carries a lot of screws and compartments, similar to that of an iPhone. Alright, so that's connected. All connections is intact now, I believe. Alright, there we go. So we can now close. Alright, next side. Snaps in place, very good. Alright. Alright. Okay, so let's see what we get, shall we? Alright, so I'm going to plug it on this side. This was the side that was giving the issue on both ports, so I'm going to plug it on this side. Alright, so getting 5 volts. Getting blue lights. And yes, and I'm getting 19 volts. So see what can get on the display here if we're going to get some picture. Alright, I hear the chime. There we go. And the battery is charging as well. Right, so as you can see, there we go. So I think you can see it on camera. Yes, so there we go. Alright, so that's a done job. So I hope you enjoy. I hope you learned something. And oh, I forgot to check back the signal with the oscilloscope. But anyway, you will get reading as usual. But that's for demonstration purpose, to see how the waveform is generated during the reading process of that EEPROM chip immediately as you plug in the charger. And that's for the power delivery side. And the battery is charging. We are getting 2.3 ampere of current. As you can see, let me see if I can pick up that zoom there. So we are getting 2.3 ampere of current right there, and the battery is charging lovely. Okay, so as I said before, I hope you enjoy, and I'll see you in another video when I will fix something for you. Okay? Alright then, bye.